Hey folks. Oh, that feels loud. Let's see how my levels there. Okay. Let me know if the mic's too hot. Okay, so we're gonna get started early today. Okay. Just getting set up here. So we're getting further with the Build Your Own Modular kit from Clacktronics. And I wanted to see if we can get 4 more modules built today. Now, so I did do some prep work. So obviously this is as far as we got last time. We got the VCOs built. I do have to repair a couple of the taps when I was tapping the holes in the enclosure. It must have been a little bit wiggly, and a couple of them are not as secure as I would like. But so that's why that tape, the gaff tape, is on there. That's holding those modules securely, where I potentially messed up the taps. But so let's get this out of here. This is our current progress. I'm just going to move it out of the way for now. We'll bring it back when we're ready for testing. So let me set it over here. So what I did to prepare for this stream today is I got all of our parts ready here. And I'm gonna potentially sneak this malt in too, because that's a super quick build. But we've got the mixer here in this section. It's a little bit off camera, but we've got the attenuverter here in this section, so everything for that. And then if we can get far enough, which I think with everything laid out like this might be pretty easy to do, but we'll see. We also have the VCA and the VCF and all the parts for those. So let's see how far we can get. And I will, as always, kind of go through the information for the modules. We'll see how this music selection goes. I've been using Epidemic Sound for the streams, just so that I don't have to come up with the music every time, and also so that there's a little bit more variation, because I mean, it's very meditative listening to the same kind of ambient loop the whole time, but I don't want to assume that anyone else enjoys that as much as I do, because it could also be considered boring. So trying to give folks a little variety to listen to. But as a result, the kinds of music that I like to listen to are, aside from jazz, Epidemic Sound has some really good jazz artists on there, but everything else is, no offense to the artists on the platform, but I find it to be a little hit or miss. So we'll see. This is a playlist I put together, but I haven't thoroughly vetted every track that's on here, so we'll see. And it's only about an hour of music, so I'm gonna have to work after that. Oh, and I tried to stay to instrumental, but I forgot I stuck this song on there. Okay, so, you know what? I didn't heat up my iron at all. Let me do that. And while I do that, let me get... I don't have anything in front of me at the moment to monitor the chat, so let me solve that real quick too. I'll be right back. In fact, let me just do this for a second. Be right back.
tastes like.
Okay. Let me just have one other aspect of this I need to solve real quick. And there we go. Okay. I had to get the phone powered because it was running a little low, but all right, so let's start with the mixer. And as always, let me just kind of run through the information in the book just to give you a little background on what's being built here. Get some things out of the way. So again, if this is the first time you're tuning in, we're building the Clacktronics Build Your Own Modular Kit. Try to get this in view. So this is a kit. It's available through Thonk in the UK and possibly other retailers, but if you go to the Clacktronics site, I know they have links on there for it. And basically, the way it's set up, and again, if you've been watching and you know all this, a little bit of a review here for you, but basically every chapter has the PCBs for the build as the chapter marker, and then there are explanations of the circuits and kind of the reasons for the choices that were made with them. So it's a good learning tool. You've got schematics in here, and the whole thing's just really nicely done. For any of you who know my stuff, you know I have no shortage of modular gear, but I really wanted to just kind of support this project. I actually pre-ordered it when it was first announced. It arrived like a year and a half ago, and it did take me until now to actually build it. There were some other projects in the pipeline ahead of it, and also I just was extremely busy with work stuff and just didn't have the time for it for a long time. But here we are. So we've gotten through a good portion of the build so far. We have 2 VCOs now, so we can start making some sound. Prior to that, everything else was more in the utility space as far as modules are concerned. So now we're getting into the mixer, attenuverter, which I like the way Ben at Clacktronics kind of grouped this stuff, because it's basically like the circuits that are related in terms of the chips they use and such are grouped together in the build, and it's been interesting for me because I'm a novice when it comes to circuit design and such, and just seeing kind of the changes that are made in order to develop a different purpose circuit around the same chip has been pretty cool, because the circuits are kept pretty simple, and yeah, I basically I think this book does a really nice job in terms of presentation and explanation and stuff, so I highly recommend it. I am going over some of the general content on the stream, but it's much nicer to hold the thing in your hand, and I don't go over the schematics or anything because it's a bit much detail to try to show on cam and stuff. So anyway, so we have the mixer here. The description in the manual, it says the mixer is pretty much the same thing as a standard audio production mixing desk. You will find when patching together a sound that you may want different signals to have different amplitudes. This simply lets you do this using knobs instead of faders. In an electronics context, a mixer is simply a voltage adder and is known as a summing amplifier. One difference from a regular mixer that typically blocks DC is that this one is DC coupled. It means the mixer can pass DC voltages from its input to its output. This is very useful in our modular system, as control voltages, CVs, are DC signals. You could use the mixer to offset a voltage. For example, if you had a plus minus 2 volt sine wave and you wanted to offset it by 1 volt, you would put the sine wave in one input and 1 volt in the other. You can also use it to reduce a CV signal. For example, if you had a 10 volt peak-to-peak square wave, you could reduce it to 1 volt peak-to-peak by turning the gain down. A caution when using this module is that because it is adding voltages, they can reach quite high levels. This is not an issue technically, as there is no module that can be damaged by these voltages. However, the op amps would start to clip and your sound or CV will be distorted. This is a quite simple build, so choose this if you have a short building session. We have a long one today, but we're trying to get a lot in, so also a good choice. Mixer module. The mixer is very literal and behaves exactly how you would imagine. There are 3 inputs, input 1, input 2, and external, each with its own named gain knob. This creates a mix of these 3 inputs to the output jack. External is a higher gain input that should allow you to connect line level inputs into the mix to bring the gain up enough to match modular levels. So basically you could use this module to give a mix of the 2 VCOs. The lower pitch one could be lower in volume than the higher, or you could mix in some sounds from the microcontroller module. Note it is DC passing, so you can also use it to create a mix of the control voltages. Specifications. Input current is on the 12 volt rail, it's 5 milliamps. On the negative 12 volt rail, it's 8 milliamps. And it's saying it's about a 30-minute build time and that it's an easy build. So, and for the circuit description, it says this circuit could have been built with 1 op amp as shown above. The inverting amplifier functions very well as a summing amplifier because of the virtual ground at pin 2 in the diagram. Virtual ground is a beneficial feature of op amps, especially for summing. For example, it makes in1 appear as if it is a resistor to ground. This is because if you increased in1 voltage by 1 volt, the output of the TLO74 at pin 1 would decrease by 1 volt, holding the voltage at pin 2 as close as possible to ground. You can remove the op amp and imagine it as a simple voltage divider with an inverted version of the input opposing it at the other end, as shown below. And then it shows, in 100 kilo ohm resistor, 100 kilo ohm resistor inverted in 1. So now it is hopefully easier to see that if in 1 increases or decreases, the inverted in 1 exactly opposes it. So it will always be exactly halfway because the 100 kilohertz, 100 kilo ohm resistors are equal. I guess I'm starting a little too early in the morning. I don't usually have this much difficulty reading. The virtual part of virtual ground means that this point is entirely dictated by the voltage on pin 3. It's not actually connected to ground. This is because the op-amp is trying to keep the voltages on pin 2 and 3 the same by varying the voltage on pin 1. As a summing amplifier, this means that the 3 inputs do not affect each other. Because the output is always opposing their changes and is always responding to the input, you get an inverted sum of all the inputs. To increase gain, we simply decrease the resistance at the input, like in 3 with a 1K resistor at R10. Now, with a 0.1 volt increase of in 3, the output has to drive 10 volts to get the virtual ground 0.20 volts, aka ground. This is how we achieve gain, and each input can have a completely independent gain calculation based on its input resistance. The way to calculate this is by dividing the feedback resistor by the input resistor. Therefore, N3 has a gain of 100 times because 100 kilo ohms divided by 1 kilo ohm equals 100. And then we have our overall schematic here, which again, I'm not going to go through the whole thing. I encourage you to purchase the book for that. Because we don't want our output to be the inverse of the input, we need to invert it again. This can be done either beforehand or afterwards. Here I did it beforehand because I wanted each input to have an input impedance of 100 kilo ohms, including the external input. The configuration is another inverting amplifier and is very similar to the summing amplifier, which is just an evolution of this simpler design. The output drives a potential, I'm just going to say a pot, set up as a voltage divider. I don't know why I always stumble over the word potentiometer. But, yeah, so the output drives a pot set up as a voltage divider. The summing amplifier input sees the signal from 1 to 1 to 0 volts ground, providing individual attenuation controls for the amplifier. As far as construction, it just says this is a relatively straightforward build, as all the resistors are the same value except for R10. This is a very good module to test soldering on, as you can't go very wrong. Always check for shorts at the power connector input. And patching notes, I'm going to skip over troubleshooting because hopefully we won't need that. And patching notes, this is a very simple mixer. The idea is you can mix the 2 VCOs at different volumes. Additionally, observe that it can mix CV voltages. Okay. And so now we have our bill of materials. I marked off all the stuff that I placed ahead of time, just with little dots so I knew. And I did not source the TLO74. I like to keep those static sensitive parts in their bags until like fully needed. So, all right. So that's the background. Let's build the thing. So let's see. Can you see well? All right. I'm trying to think the best way to organize these parts here. I guess we'll try to keep the parts in view as much as possible. So we'll do it like that. Get this centered there. Okay. So here's our PCB. And you can see the components for the interface go on this side. This is our solder side, or the back of the board basically. And as always, I'm going to start with the lowest profile parts. So starting with the resistors, working our way up. And our 10 is the 1 kilo ohm, which will be this one resistor here, and then there's 9 100 kilo ohm resistors. So, and let's just check what the footprint's looking like on here. I think it's gonna be this front. Yeah. So, or OCD or lazy, I don't know which, but. So we'll also do the diodes in this same pass because they're about the same physical profile. Got a lot of cable noise today. I have to try to figure out how to avoid that. Maybe if I go over the back of my neck. It's rubbing on my zipper, and then it like seems to translate down the microphone. So, okay. Oops. Okay. So that's all of our resistors there. We'll also add the diodes. And in case you're not familiar, a diode is basically a one-way component for current, so you can use it for protecting a circuit and for controlling flow, basically. And so they do have a polarity, so you do have to watch that. And so they're marked with a stripe on one end, so we're going to orient that with the mark on the PCB to observe polarity. Okay, those are all those components. That was pretty quick. Let's clean up the iron here because I haven't used it yet today. So we'll just clean the tip. Looks okay. And oh, you know what? It's gonna add a little bit of noise, but let's turn the fume extractor on so I'm not breathing in this. I still have a large supply of leaded solder that I'm still going through, and I try very much not to inhale this stuff. This setup isn't great because the fume extractor should really be a bit closer, but it does help. But it's so loud. I'm just kind of starting closest to me here. Got my iron set to 750, and this solder is like flux core solder, so it's got, or rosin core, or whatever they call it. So it's got the solder in there. I mean, the solder in there. It's got the flux in there. Hopefully you know what I meant. So I'm not applying flux separately is what I'm saying, I guess. And again, I'm a bit lazy. I do the resistors top down, that way I don't have to mess with like bending the legs out and stuff. The music we're listening to, I was attempting to come up with more of a sort of post-rock type playlist, but turns out material of that variety is a bit limited on this service. So this was kind of the closest I could come. So it's more like instrumental indie rock kind of stuff. It's all very happy and bouncy. I like a little bit on the darker side, but yeah, what can you do? Copyright's a thing. And I'd rather not have these streams taken down. Boy, the fan and the fume extractor feels especially loud today. Maybe my mic's hotter than usual, I don't know. Or the music's lower than usual. Might have to change the balance a little bit. Okay. That's those. That's the first layer. So let's trim those leads. And then so what I do is I'll trim all the leads, and then I'm going to come back through for just a quick round of cleanup on the underside of the PCB. That way I make sure that everything's fully flowed like through. Because sometimes it'll flow most of the way, but then it won't like completely cover the pad on the underside. So I like to just, doesn't take a whole lot of time to just real quick run through and reflow any that look a little sparse on the solder. So I just do a quick pass on the underside. So in all, it's probably not actually any faster to do it the way I do it. So I don't recommend it, but it's just, it's my approach. And I will say that I don't ever really deal with cold solder joints, so it must work. Oops. Yeah, so much of the like instrumental rock stuff on here feels like, I don't know, an uplifting pharmaceutical commercial or something. I might switch back to my funk playlist, but all right. Let's just real quick flow these. Okay. That should be good. Yep. I'm also like, it doesn't actually matter, but like I kind of run my finger over there and just make sure everything feels kind of smooth and level. Like I said, I'm a little OCD about this stuff, but I also don't generally have problems with builds, so it does seem to have benefit, so that's why I let myself continue to be sort of obsessive. But all right, gotta open this clamp a little further. All right, so we'll do the capacitors next. It's just 2 of them. It's gonna be here, C1 and C2, and they're both 100 nanofarad ceramic caps. So there's those. These ones, again, because there's space to do it, I'm gonna go top down. Okay. Yeah, and yeah, for both of those, it barely made it through to the other side of the PCB, so I'm gonna add a little bit of extra solder on the other side. So let's go ahead and do that. I'm just juggling too many things. There we go. All right. Okay. Hold on a second. Let me make sure. Okay, yeah. Just had to check that I was looking at the right pad, because the way the lead that's in there was catching the light, it looked like the hole, like it was an empty hole, but it wasn't. All right. So those should be good. This actually is a rather quick build. All right, so we have our resistors, our diodes, our capacitors. That one's a little wonky, but it's just position, it doesn't matter. And so then we'll do the socket for the op amp. And again, the way I do these, it could be considered a lazy thing, I don't know, but I just hold them in place and I just use like a helping hands to hold the solder. Now you gotta be real careful and make sure you're not touching the contact for the lead that you're soldering, because you will get a good burn if you do that. But I start at just one of the corners and just secure it. Double check on the top side to make sure it's actually flush with the board. Sometimes I'll just reflow just to be safe, even though it looked good. Like applying pressure, basically, and making sure that it's secure. And then usually I start at pin 1. That time I started in the inverse. Doesn't matter. Again, don't be touching, so my finger is safely away from that pin there that I was soldering. And then once I do that, then I'll go over and just, so I have the opposite corners secured, basically. And then from there is when I go in and just do the proper soldering. And I will usually reflow those once I get the rest secured. Obviously, you don't want to just start reflowing those before you have other solder on the board, or the socket will just fall out, or at least get misaligned if the other corner is holding it in. So. Okay, so I've got the socket. There's that. Looking good. So let's add the power header. So you see the notch in the silk screen is there, so we'll align with that. And that's pin 1 there. So again, same technique for these. These are a little bit trickier the smaller they are to hold them without touching the leads, but because they'll kind of, what tends to happen is they'll try to go off on an angle like that, so you have to make sure you're putting the right kind of pressure in. And I also tend to be very OCD about making sure they're centered in the holes on the PCB, just so they so that it looks nice and flush with the silk screen. But again, this is just, none of that really matters for functionality usually, so to each their own. I don't recommend being as concerned about these things as I tend to be. It definitely slows down my builds, but okay. So again, both corners secured, and then I'll just put it in the grip and run through. Okay. And with ones like that, I'm just gonna triple check under the microscope and make sure that nothing is anywhere near bridging. Nope, everything looks good. Cool, because when I'm soldering these, sometimes the reflection of the flux, for me and the way my eyesight is, it can sometimes be a little difficult to tell if everything is truly separate and not bridged. So I do like to double check that sometimes under the microscope just to be safe. So now I mean, that's as simple as this thing is. I don't place the ICs until I'm done with all the soldering, just because if they're sensitive, there is a chance you could damage the chip. I don't do it. I'm just very careful that way. So then we want to place the hardware that needs to align with the faceplate. That one, you gotta sometimes give these a little squeeze to get everything in. And these, all 3 of these pots are exactly the same. They're all 100K pots. So I'm not worrying about what goes where. I'm just putting them in. These leads are just a little bit bent. Okay, I don't. Alright, so there we have 2. And then this one goes the opposite direction. So there's that. And then we'll place the 4 jacks, and they all, as always in these builds, share a ground. So just gotta make sure that those leads are all in the right place. I don't know how in focus this is when I go, because the camera's like focused for the level where I'm doing the soldering usually, so I don't know if this is blurry. I'll have to take a look. But so then we place our faceplate, and so you can see the faceplate's making contact with all of the components. So then if we just go ahead and secure these down, and I just hand tighten these for this kind of thing. That one's been a little stubborn. It feels like there's a burr in there or something on the threads. There, we got it. Okay, so that's the jacks, and then we'll do the same thing. We'll secure the pots. Again, just hand tight. Okay. Okay, so all that is flush, everything looks good, it's seated well, everything's secure. So then what I do in these cases is I will put the faceplate in the grip, and sometimes I'll use both of them just so that it's, because it can get kind of, it'll flex a little bit when you get down to the lower parts otherwise. So then we'll just go through. Let me see. I'll clean the tip of the iron. Actually forgot to do that for a while, so it's, yeah, that looks good. And then we'll just run up through the jacks and then do the pots. Being careful not to make contact with the components that are already on the board, obviously. Yeah, I'm still gonna have to figure out a better arrangement for the fume extractor, because it doesn't do the greatest job. In this arrangement. It needs to be pretty close to the work for it to really do a good job pulling everything out. Okay, those are the jacks. Sorry about that. So let's get the leads here. Now there are different schools of thought. I've said this on prior streams too. As far as soldering these tabs, I just do it because I find it makes everything more secure, and it helps with any stress that the knobs might take, so that you're not stressing those leads instead. It's literally never caused a problem for me. The only issue is if you need to remove the part. Sometimes it can add complication, but I have a desoldering workstation at this point, so I don't really worry too much about that. If you're, obviously those are a little bit on the expensive side, so if you don't have something like that, that would be the one consideration maybe in a case like this where they're mounted to the faceplate. You might not have to worry as much if you expect to have to replace them at some point, but again, I mean, I've built a lot of modules at this point, and I always solder these, and it has really very rarely caused me any issue. And even when I have had to make tweaks or replace something, a solder sucker will get it out. You do have to work a little at it, but it's really not that big a deal. Okay. Okay. So we have to place the chip, but otherwise this module, for all intents and purposes, should be complete. I'm just taking a look at everything. Everything looks clean. Now, in this case, I'm not really doing anything with the ultrasonic cleaner for these to clear the flux off the board. I normally would, like at an earlier stage, before the pots are in and stuff, I would oftentimes do that work. Sometimes even with the pots, I'll just drop it in there, but I'm not too worried. I do understand there that the flux can cause issues over time and irregularities, but again, maybe I just haven't had any modules long enough, but I've yet to experience that problem. Sorry, I'm just making sure all these knobs are perfectly aligned so that they all look the same when they're in their min position here. Yeah, okay. Nope, see that? That's what keeps happening. They're like just a tiny bit off from each other. It's like one notch on the head or something. I don't know. Okay, yeah, that looks pretty good. So, let's get the op amp out and place that. That needs to go in that socket there. So we've got our anti-static bag, and I think, yeah, we've got 4 of the TLO74s here. And so I always use one of these little tools to straighten the legs on them, because sometimes they can be a bit tricky to get into the socket otherwise. And then you always want to observe orientation on these and make sure that pin 1 is where it should be. And in this case, it's a little notch in the socket and then a notch on the chip itself that easily designates that. But you can also look at the pads usually, and I believe that's the case with these PCBs. I believe pad 1 is a square and the rest are circle. But yeah, so that's a completed module. Now I am going to wait to test this until we get through at least the other of the first 2 builds here. So that's done. We're gonna put that aside for now and come back to it. So I'll just put it. This little plastic tray here is actually an anti-static tray, so that's kind of nice for, in fact, because this other build uses this same chip, so I'm going to go ahead and just put it in there while I have them out. Alright. I'm going to pause for 1 second here and just check. Wait, why? What's going on here? All right. Sorry, I got scared because I got the sort of stream summary email from Restream as if my stream had quit, but it looks like everything's good and it's still going. I don't know what that was about. Okay. Alright. Looking good. And where are we? Let's see, so we're probably about halfway through this music playlist, right? Where are we at? Yeah, roughly. Okay. Alright, so let's get to the attenuverter. Make a little room here again. We'll just real quick go over the description and the background. So that's one module down. I'm trying to get 4 like full-on modules and one real simple mult done on this stream, so that's a good start so far, I'd say, in the first 30 minutes. Let me grab a pen here just to give myself the notes that I need. Where did I put my pen? I don't know if I date myself by mentioning a Kids in the Hall reference, but anytime I lose a pen like that, I just immediately think of Bruce McCullough going, my pen, someone stole my pen. Anyway, there it is. Okay. Let me just mark this off. We've hopefully got ourselves a mixer now, so. Bam. This is just for my own reference so that when I see this page, I know everything's been completed. Alright, so attenuverter. We'll go through the description here again real quick. Try to get this on screen a little bit. Alright. Can probably do a little better than that. There we go. Alright, so it says, oh, you know what? For now, I'm going to go ahead and turn the fume extractor off so we have a little bit of a little more silence while. Alright, so attenuverter. Attenuverter is a name very specific to modular rather than electronics. Attenuverter is a portmanteau of attenuator and inverter. A voltage attenuator is a circuit that reduces the voltage of a signal. A voltage inverter is a circuit that flips a voltage upside down, e.g. plus 10 volt becomes minus 10 volt, etc. So, an attenuverter does both. Attenuverter circuit description. Oh, and so the little diagram here says like 0%, 50%, 100%, and negative 100%, 0%, 100%. Attenuverter circuit description. Consider the attenuverter like a regular inverter when the pot is turned all the way to the ground. So when pin 10 is at 0 volt, it makes it a simple inverting amplifier, and the voltage out is the inverse of the voltage in. Plus 5 volt will be negative 5 volt. When you start to turn it back towards halfway, the amplitude will increase from negative 5 volt until it reaches 0 volt, somewhere near the middle. Is that just one page? I thought I had 2 pages there. Okay. However, when the pot is turned all the way up to match the potential of the input, we get a non-inverting amplifier, and the output signal will be exactly the same as the input. When you start turning it down to halfway, it will reduce the output until it reaches 0 volt ground. To use this module, we can feed in CV signals and adapt them to suitable ranges to match what we are controlling. For example, feed in an envelope triggered by a keyboard, and we can reduce its output voltage and feed it into a VCO so it only slightly bends the pitch. We can attenuate the signal so that the pitch of the VCO only increases slightly when we trigger the envelope. Alternatively, if we turn it towards inverting, it will drop down the pitch down slightly instead, creating another effect. Attenuverter module. For a start, the two outputs, attenuvert 1 and attenuvert 2, both put out a voltage based upon their corresponding control knobs of the same name. With nothing connected on an input, fully clockwise they put out plus 6 volt, and fully anti-clockwise they put out negative 6 volt. This can be useful if you want to control both the oscillators at the same time with one knob as an example. A signal plugged into input 1 can be attenuated and inverted by the control knob, attenuvert 1. Full clockwise, the output signal will be 1 to 1, the same as the input. Fully anti-clockwise, it is inverse. 0 volt is somewhere in the middle. It is not exactly halfway, you have to feel it. If you look at the front panel, you will notice an arrow going from input 1 to input 2. This means the input 2 jack is normalized to the input 1 jack. Basically, 2 will follow 1 until another jack is plugged into input 2, breaking that connection. Specifications, it's 5 milliamps on the plus 12 volt rail, 8 milliamps on the negative 12 volt rail. It says it's another 30-minute build and that it's easy. And we have the diagram. Okay, this is basically the same as the last one with some different resistor values, and otherwise, I mean, it's literally like the resistor values are kind of the only thing that's different in terms of parts. So for construction, it says this is also a very simple module. Most of the values are the same. Just follow standard procedure. Again, we'll skip troubleshooting for now. Hopefully we won't need that. Patching notes. The attenuverter can be used in many ways. Each knob can provide a static CV plus minus 6 volt, or it can take a CV input and attenuate and invert it. Note the second input is normalized to the first. This means you can take one CV signal and create two different versions of it with the two outputs. Cool. So we're going to be starting with resistors as always and diodes. So it looks like R6 and R11 are the 1K resistors, and then everything else is the 100K. So let's get started. Okay, so we'll grab these parts first, because that's what we're going to be starting with. So okay, so R6 and R11 are these two here, which makes those pretty easy to isolate. They're just right there on the board. So let's start with those, because then we don't really have to think about the values again once we get those done. So I'm just going to assume at this point that we'll be using the smallest gauge on the little leg tool. I don't know if that thing has a proper name, but call it Bender, like Futurama's robot of fame. All right. Okay, there's those. R7. What it is with this cable making so much creaky noise today. I don't know if you can actually hear that or if it's just in my headphones, but the headphone cable is experiencing a lot of friction on garments and things, and it's making all sorts of creaky noises, and at least in my headphones. Hopefully not in the mic, but it might be in the mic as well. I don't know. Yeah, we can, let me, I always forget to move this a little north so that it's in frame better. There we go. Okay. Oops. Getting overzealous there, I just bent it off. Okay. Alright, there's those. Let's place the diodes. In this case, they're basically right next to each other in opposite directions. And they tend to be on these PCBs the next gauge up on this little tool here. Yep, that worked. Okay, and then this one there. Yeah. So I don't know. Let's get that in there first. Okay, that should be good. So I don't know how well you can see on camera there. There's also a bit of a glare, which is probably not helping. But basically the polarity is opposite on each of these. Okay, so and I tell you what, we're actually getting a kind of early spring weather here. It's getting up into the 70s and stuff lately, and it's getting pretty warm. My studio tends to get kind of warm once we get into this weather because I often have like very high output in terms of heat. Analog synths just kind of on because I'll be working on something and I don't want to really interrupt it. But the modular has to get turned off once we get above like 50 or 60 degrees outside because otherwise it just heats the joint, which you don't need in warm weather at all. Plus I always worry about the longevity of components at that point because everything gets so warm. Anyhow, let's see. Clean this tip again. It doesn't look bad, but just to give it a little boost. Alright, and also, let's get this back on. We're going to get some noise again from that. Sorry. Oops. All right. There we go. It's really struggling to heat that pad for some reason. Okay. All right. Okay, one more. All right, so let's clean up those leads. Trim all those. That one was still pretty hot. Okay, let's see. Alright. Let's clean up those. Just reflow them real quick. Make sure there's enough solder on the other side of the board. Oh, let me clean that tip. It's got a little bit of a blob going on there. Alright, nice. Okay. Blah, blah. Almost done. Okay. That's everything for that round. Feels nice. Everything's smooth, good. Nothing jagged. No, it's a little funky to the silk screen, but that's alright. No harm done. Alright, let's do the caps. I think it's just, yep, once again, just two 100 nanofarad. So we'll place one. And we'll place two. So yeah, again, the interesting thing to me with, and again, I'm a bit of a novice when it comes to circuit design and stuff, but I find it pretty cool that these are such similar circuits. I mean, they do a very similar thing in a way, and yet not. So it's cool to see like what the variance is between those two functionalities when you're working with the same op amps. It has me, I think what I'm probably going to end up doing at some point in the future, not too far from now, will be to just, you know, take these circuits and kind of breadboard them, and so I can play with values of things and stuff and see how it affects them so I can get a better sense. That's looking good. Let me just do the cleanup real quick. Alright, very good. So I'm just gonna, this time, because last time I didn't do this, this time I'm gonna mark off as I go. So we've got the capacitors, we've got the resistors. And our diodes. So we'll do the sockets next, or the socket and then the header, to be more precise. So again, orientation, notch in the socket there. We'll place that on this end. Pin 1 is here. And same technique. Just gonna hold it in place. Careful not to touch the leads I'm soldering so I don't have a fun burn from it. And basically just gonna use the helping hand to hold the solder. I mean, that's technically not a helping hand, I guess. It's just an alligator clip on a on an arm, but okay, so those are secured. It's flush with the PCB, everything looks good. So I'm gonna flip it over, pull this out, and do the rest of the soldering. Okay, that's done. Looks good. Let's get the power header on there. Again, notch is here on this side. Red stripe, -12 down there. Just gonna place that. Once again, doing the same thing here with gonna hold it in with my hand. And again, this might be one of those like don't try this at home kind of things, but this is how I do it. Okay, that's one. Just gonna check again the orientation to the board, and it looks flush, it's good. So we'll just go ahead and solder pin 1 here. Same technique, and there we go. And let's finish up in the grip. Okay. Once again with this one, same as last time, just because of how the flux kind of catches the light, I'm going to check under the microscope, make sure there's no bridging. And we are good. Looks pretty good to me. Alright, so then I think, yeah, that takes us down to the hardware and the faceplate. So let's go ahead and place the pots. So there's that one. There's that one. Those feel secure. Again, shared ground, so we'll get that placed like that, with the next one sharing that same hole. Okay. so there we go. So let's put the faceplate in place. Alright, so everything's looking good and solid there. Let's lock the jacks down. Okay. Now we'll lock the pots down. Oops. It's like when I was placing the parts for this, it looks like I forgot how many pots this one actually had, because I have an extra set of nut and washer in there. That's alright. I'll have to put them back in the parts bag so they don't get lost. Okay. So that looks good. Everything's secure. Again, we're holding off on placing that op amp till we finish all our soldering, just in case. Don't want to do any damage. Gotta clean the iron. And let's go ahead and, how are we doing it? Yeah, it's visible. Okay. Alright, there's those. Carefully, I'm going to come in from the top here so I don't make any contact with the socket for the IC. I got shaky hands lately. I don't know what that's about. They used to be extremely steady. Getting old. I don't actually view myself as aging that terribly, but, you know, things do change. Okay. One more. Cool. So, just real quick, gonna make a run under the microscope here just to make sure everything's looking good. Yes, sir. Doorman. Okay. I think we're in good shape. Everything's looking good. I'm gonna place the IC. And then I guess we have a decision to make whether or not to test these modules or continue on to the VCA and VCF and then test everything together. I think that might be my preferred approach, but we shall see. Alright, so there's that. Let's place the knobs. Just gonna lightly place them on there to get them aligned, to make sure they're both good. That looks... actually, I think that's better for the range. Yeah. Alright, we'll go with that. Alright, and we're just making sure that, yep, so they're aligned well. In case there's glare, I'm moving that around so you can see. But, alright, so now, that's 2 modules. We've got the mixer, we've got the attenuverter. Slightly different circuits, both based on the TLO74 dual op amp. And let's keep going. Let me just stand up and stretch a moment here. Oh, actually, let me finish marking this. Alrighty. So the next will be the VCA. And yeah, I'm gonna clean up for a second first though. Just get rid of all these clipped leads. Remember when I first started doing DIY stuff, I actually, for some reason I would save these. I mean, I still have some, because they are good for like doing little repairs and things if you need just a thin piece of, like, all of my solid gauge, like solid core copper wire is a bit thicker gauge than this stuff, so sometimes it's nice to have them for repairs and things. But I used to save all of them as if I was going to like make some project with them at one point. I have no idea why I did that. I eventually threw them all out, but I do still have a small pile for repairs. Alright, let me place all this stuff. Oh, I'm getting wrapped up in my chair here. 1 second. Alright, hold on. I'll put those in shot so that anyone joining can see our status here. Alright, 1 second. I'm going to put these headphones down for just a moment. Alright, so yeah, I would say that a build time of a half hour is pretty accurate for those, because we're about an hour and 11 minutes into the stream. We've got both of those built, and as I've said many times on previous streams, I'm slow, so someone not as slow as I could probably make even faster work of those. You know what, let's build the mult real quick, because that one's so simple. just get some things out of the way. And then I think what I'm going to do is I'm going to transfer the parts for the other two modules into this tray, because it's working out well in terms of keeping things organized. Feels good, so we'll go that route. So this is all that's involved in this mult. It's literally just the PCB and jacks and a faceplate and some jack nuts. That's it. So let's build it real quick. As always, they oh wait, maybe not. Do they share a ground in this one? Maybe not. I was about to speak out of turn there. Oh yeah, some of them do. I see. And in case it's not obvious, I'm just assuming the orientation and everything in the ground based on the fact that the PCB design makes it nice and obvious, because the ground is a differently shaped pad than the rest. I think the one thing that I had to reference last time was just which way this PCB oriented. Okay, no, that's right. J1 at the top there. Okay. Alright, so like the other stuff, so we've got those in place. I'm going to go ahead and tighten down the jacks. Assuming I can get these nuts on here. Please. It's fighting me a little bit. There we go. Okay. There. Alrighty. Okay, so that feels secure. Everything looks good on the back. Let's get to soldering here. And I'm gonna just hold both ends again so it doesn't flex too much on me while I'm working. Because everything's nice and settled, so I don't want it to shift. Okay. Gonna clean the tip of the iron again real quick. I just realized. Okay, hang on a second. I'm adult. I'm soldering on. I have the PCB flipped. It's supposed to be the other way. I don't know that it really matters with this particular build, but let me just fix it because that's very silly. Gotta get the desoldering iron up to speed. So in other words, these like the J1 through J7, those should be facing the other way. To be fair, it does say back and then front on the other side, but depending on how you're thinking about it, I was thinking front as in front panel. But let me just go ahead and clean this up, flip it around. Whoopsie. Okay, that should have gotten that. Yeah, if you can avoid this sort of thing, I do recommend avoiding it. Because this is a silly problem to have. Alright. It's still not completely loose. Let's see why. There we go. Oh, this is gonna be fun. Oh, it is. Yeah, it's that ground right there. I think that's where everything's kind of stuck. Maybe not. There we go. There we go. Okay. So, silly me. Laying this out the wrong way. Again, I don't really think it would have even mattered, but I'd rather... I'm going to have to get a better look at this while I do it. Is our music over? Sounds like the playlist might have ended, which is a bummer. I'm gonna need just need something to get in there so I can. No, those are too big. I need my tiny pliers. Plus, we need music, so let me even if I just restart that playlist. Alright. Yeah, okay. We'll start over. Why not? Or what do we have? There's Alright. Pardon me interrupting the music again here. I'm gonna... Alright. Okay, let me get my... I need like tweezers so I can... Right now the two ground leads are kind of spread apart and I have to get them cooperating because they need to both end up in the same hole in the PCB. So let's get that. And they're kind of all over the place. Alright, let's see here. What's going on, my dudes? I don't know why electronic parts are gendered in any way, but I've always thought, like, probably on some level kind of sociologically interesting when, because different people will refer to inanimate objects with different genders. And I always found it kind of fascinating, first of all, that we do that, and secondly, like, that we have different preferences in that regard. Sorry, I'm still just struggling to reverse my mistake here. Okay, we've got one last ground lead that is not where it needs to be. Let me try to get that in place and then we should be good. Just had to find a way to complicate the simplest module on the face of the earth, huh? Right. There we go. Oh, except this one escaped. Okay, you go in there. Get in there. No more messing around. Alright. Alright, back to normal. That looks good. Okay, let's solder this the right way this time. Once again, would not have mattered at all, I don't think. It's not like there's any orientation concern or anything here, but might as well do it the right way. Okay. Take two. See how long it can take me to build the world's simplest module. Okay. Alright, cool. Done. It did feel like one of those jacks, or the nuts on the front was potentially loose. Yeah, this one. Okay, let's just tighten all those down, hand tight. Should be good enough for now. Secure that one again, and this one. Alright. And aside from... Uh-oh. Darn it. We've got a stray lead. It got out. I think, let's see, how close are those two? Well, alright, so don't make the mistake I made and have to resolder everything after you put it together. That was so dumb. Probably should have undone the faceplate and put everything together that way, because I'm going to have to just go ahead and kind of solder these two pins together, or leads, or whatever you want to call them. Just going to use this to hold this. If it's going to hold it, is that holding it properly? Nah, that's not going to work. Cute idea, but no. Alright. Well, without taking this whole darn thing apart again, but I might have to. Alright. Now, hopefully I can just apply some pressure with the tip of the iron and get those to touch, and then I can hopefully solder them. I don't know how high this thing goes. Can I hold it this way? Yeah, okay, cool. Probably the other end though, because I want to do the soldering at that end. So. Yeah, this is all a bit silly. If I had just oriented the PCB right the first time, I wouldn't have these problems, but here we are. So let's just see if I can kind of coax that over. This is where having like a wider flat tip on the soldering iron would be helpful, because this is a very narrow tip. So having it make proper contact is kind of tricky. Alright, let's see. Let me just... very stubbornly like springing back the whole time. Alright. There we go. I can just hold that in place and get a little bit of solder to join those. Luckily it's the ground, so I can just kind of join these two together and it'll have the same effect. Alright, it's sloppy, but it's just a malt. Yeah, it'll work. I'm just going to test continuity on that, make sure I actually got everything soldered there, but it should be fine. I'm confused. This song, I thought I had the instrumental version in here, and instead I seem to have the vocal version, which is strange. But anyway, let's just see. So, oops, sorry about that. So let's just see if I check that, and then yeah, we're good. We've got continuity between both of those leads. Just want to double check. So, yep, and yep. Okay, we're good. Okay, silly mistakes, but there's if you need a way to mess up a really simple module, just find a way to flip the PCB and solder it on the wrong side. Not that it mattered, but you know, I couldn't leave that mistake in place. That was just a little bit too glaring. So there we go. Now we're good. So there's that. So add that to our little pile of completed modules here. I'm going to move these though, actually. So now, I think what I want to do is we will take our finished modules, set them aside for a moment. And we'll take the parts for the VCF, which we'll do second. Those will go here. Okay. I just dropped a washer. But I guess that's why it's nice to have this extra one over here. I'll just drop it in there and then I'll collect the other one off the floor in a bit. Alright. So I'm just taking the parts that I already set up for the VCA and VCF, and I'm just transferring them to this anti-static like part tray that I was working with for the other modules, because it's very convenient and a little bit more organized than the this sort of like blue mechanic tray that I usually use otherwise. Alright, So there's our caps, transistors, sockets, pots with hardware, knobs, Yep, I almost overlooked the diodes in there. Glad I caught them. There those are. Okay. So, what have we done so far? Well, we have the mixer, we have the attenuverter, and we have a mult. And that's just a blank plate. So we are going to do the VCA and the VCF, and then we will have completed 5 modules today, which is a pretty good run. So let's see where we're at. Okay, that's pretty well centered on screen. Move it up just a tiny bit. Let me get this cord for the iron out of the way for the moment. Alright, and let's look over the literature for this module and just see what the background is and everything. Run through that real quick. I'm going to turn the loud fan off. Okay. So the VCA, or voltage controlled amplifier. I'm going to move this guy out of the way for a moment. There we go. And for the record, I just always like to mention that I did get Ben's permission at Clacktronics to run through this material on the stream. But I do highly encourage you to purchase the book and the kit. It's very well done. It's very well organized. I mean, it's a thonk kit, at least the version that I got. So I think that may be the only version currently, but and they always do a fantastic job with kits. They're always extremely well handled. And I have to say also that this one in particular, I got the kit, and I'm in the US, obviously. Thonk is in the UK. And I received the kit, and then like a week later, I think, I got another package. And it was just a couple diodes. I think it was like 4 diodes or something, and it just had a note saying, like, we realized there was an oversight with the kits, and here are some missing diodes, basically. I mean, I'm paraphrasing, but which is so classy, in my opinion, because I have gotten lots of kits that were incomplete over the years, and certainly never, I mean, I've gotten, you know, like, sorry about that, you know, here's where you can get the parts kind of thing. And occasionally, like, we'll send you something, but I've never had like an error corrected like that before I even noticed it, basically. So I was really impressed with that. But I'm always impressed with Thonk. They do a fantastic job on things. And similarly, with the work that Ben did on this with Clacktronics, this is, I mean, it's a really well organized kit. It's very informative. And I think by the end of it, you really get a sense like you understand what you built, which is really cool. So very good first modular build and learning tool. So if you're trying to understand sort of the nature of the circuits and stuff. So voltage controlled amplifier, a very useful tool in all synthesis, is a way to control amplitude. It lets us move away from a static drone to defined notes. This is done by patching the VCA with an envelope control envelope control voltage triggered by a musical composition device such as a sequencer, keyboard, or computer-controlled CV tool. Its basic function of controlling the amplitude of the signal can have a surprisingly musical effect on the sound. It can also make a tremolo sound if you plug in an LFO. So far, after working with the mixer and attenuverter, we have seen amplifiers that can increase and reduce the gain of a signal using op-amps and resistance voltage dividers. These circuits... Was my hat in the way there? I don't even know. Anyway, these circuits all rely on changing amplitude through resistance, and they do not offer a way to use voltage to change gain, which is the basis for modular control. A pot changes voltage only downwards as it is used as a voltage divider. The input voltage is divided by the ratio of the two resistances. The change in that ratio is related to the mechanical position of the knob. To voltage control this, we would have to put a motor on the knob or find a way to influence the resistance with a voltage. Historically, there have been ways of doing this with resistors that change with light, called light-dependent resistors, and then influencing the resistance by driving an LED or lamp with a control voltage, but these are becoming harder to find because all of them are made from cadmium sulfide, an environmentally banned substance in many countries, and it doesn't work very well anyway. We're going to use the operational transductance amplifier, which is an old IC but still an affordable way to build VCAs. It relies on a special part from one manufacturer called the LM13700, but it has been in production for decades. It is like a regular op-amp, but with two main differences. First, it is a transductance amplifier, which means the voltage signal on the input creates a current signal on the output, as opposed to a regular op-amp, which creates a voltage output instead. Secondly, it has variable transconductance. Sorry, I'm making sure I'm reading these words correctly. It has variable transconductance gain controlled by an extra pin, unlike the op-amp, which has fixed high gain. The LM13700 contains two of these devices. This means we have an amplifier whose gain can be made to be voltage controlled, and it can change our amplitude all the way from silent to full volume, perfect for creating notes. VCA module. A voltage-controlled amplifier is exactly as it is described, an amplifier with voltage-controlled gain. This is useful for adding nice envelope decays to a sound when playing with a keyboard or for tremolo. The module contains two VCAs that are completely functionally separate. There are three connections and a knob for each. In, where you feed your signal to be changed in, out, where you get your sound back out, and CV, which is where you control via voltage. The initial gain is set with the corresponding amp knob. Fully counterclockwise, it is silent, and clockwise, it is a little louder than input. Putting in positive CV will add gain from the amplifier, so if you are using an envelope, for example, the gain should be set to 0, and the positive envelope voltage will open up the VCA and make the sound come out. Specifications are 2 milliamps on the plus 12 volt rail, 2 milliamps on the negative 12 volt rail. Says it's about an hour for the build, and it's a medium easy build. VCA circuit description. If you have only just learned about op-amps, then OTAs can be a bit confusing. For a start, there is no feedback, which seems odd. Actually, the reason we use feedback with op-amps is because they have very high fixed internal gain. For example, the TL074 has an open circuit, no feedback, voltage gain of 1 million times the input. Here's the actual complete schematic for one VCA. It is just repeated twice in the final diagram because there are two in the module. Audio passes into the positive input of the OTA. The difference between the two input pins is the signal, which is multiplied by the transconductance of the amplifier as set by the pin 16 bias current. The two 1K resistors are there to minimize the offset voltages within the amplifier. You do not need to worry about why for now. The constant current signal comes out of pin 12 and is converted into a voltage by the 22K resistor. This is because Ohm's law tells us that voltage is the current times the resistance. Buffering is provided by the Darlington transistor, which is part of the LM1300 DIP package. It is not considered a very good buffer as it is just a Class A transistor amp, but it is good enough for us. It then passes through a capacitor to remove the DC offset caused by our buffer, especially where there is no gain. Now you might have noticed something a bit weird about the transistor that is connected to the bias input pin 16 of the amplifier. This is what is known as a common base amplifier. It allows us to have a low input impedance and a high output impedance. The low input impedance lets us mix the inputs without them affecting each other much. The series resistors from the pot and the CV input set the current going into the PNP transistor based on their respective voltages. Pin 16 is also known as IABC, which stands for amplifier bias current. This current sets the transconductance of the amplifier, which in turn affects the gain. It has a maximum current input of 2 milliamps, but here that is not a problem because if 12 volt was on the jack input, the current would be 1.2 milliamps, which would be pretty loud and distorted, but not enough to destroy the amp. The 22K resistor on the output of the buffer is simply the emitter resistor for the output Darlington driver. It is connected to negative 12 volts so it can swing below ground without cutting off. And then I use a 1K resistor to help with output passive mixing and output short circuit protection, and a 100 N capacitor to remove DC offset. Because of the poor quality buffer, as mentioned earlier, it will pull to negative 12 volt when the gain gets too low, so removing DC is a hack to resolve this problem. This means the VCA is only really for audio signals. For construction, it says this is a very straightforward module that follows the standard way of building. Be careful not to confuse the transistors. I once accidentally installed a 2N3904 instead of a 2N3906, which will completely silence the amp, and it took me hours to find the mistake. Yeah, that doesn't sound fun. And that's a good point, but I'm pretty sure we got the right things here. Let's just double check. 2N3906. So we should be good. And then we'll skip troubleshooting for now. Hopefully we don't need it. Patching notes, it's pretty self-explanatory. This can be used with the LFO and envelope to create amplitude effects. LFO will create a tremolo and the envelope will create a note sound. Use the attenuverter to lessen the LFO effect. Okay. And the notes here, it says, due to limited space, this module will not fit in the rack if there is a connector in the power bus below. This was a limitation caused by packing it all into one PCB, so the connector has to be at the top of the board. Luckily, there are plenty of empty IDC sockets in the power bus, so just make sure nothing is plugged in below it. Again, ground pins are shared on jacks. Fit both before soldering them. Yeah. Okay. So let's start with the resistors as always. So we've got 6 1K resistors to start. Gotta figure out which ones are which here. Alright. I think these are our 1K. I'm just gonna verify real quick. I did not mark these resistors when I cut them from the tape, and so just to be sure, sure these are 1K. Yep. With a slight tolerance there. We're right around 1K, so that's good. Okay. So we're going to start with R2. Which is here. R4. Which is here. R9. Which is here. I might have to figure out a different solution for these lights. There's a lot of glare on that in there. What if I move it? Yeah, maybe we'll go, how about there? That's a little better. All right. R10, which is right next to R9. R11 and R12. There's R11. Guess I didn't bend that cleanly enough. 1 second. I'm just going to straighten out this lead and rebend it because that was not sitting correctly. Alright, so R11. There we go. R12. That's better. Okay, so then our 10K, we have 5 of them starting on R13. So I believe that's going to be these. I mean, there's 5 resistors there. It's pretty self-explanatory, but I'm just going to double check to be certain. Oops. Yep, 10K, right on the nose. That's good. Some of these tracks are so funny to me. I feel like there should be a narrator, like voiceover, telling me the benefits of some product. Okay, so R13, which is here. R14, which is right next to it, basically. I'm gonna have to do a little extra work on the curation for this music next time, but there's always, it seems like every stream there's something that I end up doing very last minute right beforehand, and this time it was the music. Oh well. Wait, was that R14? I should be marking these off because I lost track. Yeah, that was R14. Okay. 14, so then we want 15. Which is there. 17 and 18. There's 17. Oh, come on. 17. And 18. It's flexing a little more than I like, so I'm just gonna put this here. Oh, and I just noticed that I never cleaned this little bit off the PCB. That's better. Okay. What's next? Alright, so 422K, which is going to be these, and I will just triple verify just to be certain. So we're expecting 22. Yep, 22.11, close enough. Within tolerance. So that's going to be R5, R6, R7, and R8. So here's R5. R6. R7. And R8. Okay. And finally, 100K, so R1, R3, and R16. So once again, we'll just verify, I mean, close enough, 99.9. I see this track. I want more like this right now. This is what I'm in the mood for. Alright, so R1. R3. And R16. And just quickly, before I add the diodes here, which there's only 2 of those. Okay, there's that. Let me just do something real quick here. What are we listening to right now? Let's just see. Oh, I guess there's only a couple songs by these guys on here, and it doesn't look like they're all in that style. Okay, never mind. Alright, I'm gonna switch to a little bit of a different music vibe just because this is where we were last week. It works well for me, but go to the Afro-funk kind of end of the spectrum here. Alright, so let's add the diodes in real quick. So there's that. And this. Alright, gotta turn the fume extractor back on again. Can't get any closer. I'm just gonna make some adjustments here to try to get it a little bit closer to the work, because it's not doing a great job of extracting the fumes right now. It's just kind of occasionally pulls some things in, but alright, that should be a little better. Oh, and let me okay. Of course, it will probably mean it's a little bit louder too when I'm close to it here, but I'm just gonna have to deal with that, unfortunately. Alright, so let's get this done. Oops. There we go. Clean the iron again. Alright, we'll just start on this side and work our way over. That's much better. Also louder, but at least it's actually removing smoke now. Alrighty. I'm gonna clean these up a little here. They're a little bit blobby. Okay, well, might end up pulling a little bit of that solder off because it's a little bit much, but. One thing I should probably sort out is like an easy microphone mute, so that let me get that clamp's a little too close to that pad. That's better. Okay. Would help if I soldered the diodes. Not sure why I skipped those, but okay. Alright, that's looking pretty good from there. Let's clip those leads, clean it up. Yeah, it does look like a couple of these I'm going to have to flow a little bit more solder onto the pads on the underside, just to make sure we get solid connections. Oops. let's go through and clean those up. Clean the tip of the iron. Whoops, gee whiz. Putting so much pressure, it slipped out of my hand, I guess. Alright. I can't tell if... I never know if the brim of my hat is blocking the view. I don't think it does, but... Just about. Okay. Looks good. Okay. So we've got our resistors and our diodes. Let's do caps next. Let me mark things off here. So all of the capacitors are the same value. They're all 100 nanofarad. Okay. So, oh, I'm grabbing the capacitors from the wrong set of parts. Great idea. Alright, so all four of these are the same. We've got C4 there, kind of working backwards. C4, C3. C2 and C1. Okay, so that's the capacitors. Let's just get this back in the clamp again so it doesn't move around too much. Alrighty. clean. Whoop, jeez. Butterfingers today. I'm gonna clean the tip off again here. Okay, that looks good. And again, because there's space, I'm gonna go top side with these, but it's really just more to anchor them, so I might this time only just do one. I guess I'll do both. Why not? Doesn't take long. Okay. There's those. Let's clean the leads, flip it over, reflow anything on the underside that needs reflowing. Okay. Okay. Looks good. So then, let me just mark those off. So we've got the 3906s. I guess maybe I'll do those next. No, actually. Well, what's the placement? Yeah, no, that should be fine. Let's, I'm gonna go ahead with the socket first. Alright. Let's get one of these over here to hold this. I'm just making contact with that, holding it flush on the PCB. And then let's just go ahead and anchor that pin. I'm just going to put downward pressure and reflow just to make sure that it's as flush as it can be, which it is. It's good. And then we'll do the opposite corner. Okay, so that's good. And then let's just put it in the clamp and Alright, so that's good. Looks solid. Everything's good. Let's place the... Yeah, let's go with the power header next. Actually, no, you know what? I'm gonna do... the 3906s first, and then the power header. So with these, orientation matters. You want to follow the silk screen on the board. I'm going to place that like that. And this here. And for these, I'm just going to solder one leg on the top side of the board just to get them anchored and solid so they're not moving around on me. So I'll do this outer leg here on this one. And I'm just also going to like reflow it a little bit and just kind of place that where I want it to be orientation wise, and then I'll do the same thing, outer leg. And just kind of gently hold it, reflow, let it cool a little bit, let go. That looks pretty good. Not perfect, but there we go. That should be good. Okay, so then just gonna flip and we'll start on the inner legs and move to the outer legs so that we don't undo that anchor point. Okay, let's clip those leads. Barrier eye protection, kiddos. Alright. Those look good. Not too bad. So, we've got all that. Let's do the power header. So, same technique as always. Just going to hold it in place there. It's a little harder on this one because it's right at the edge of the board, but not too bad. Whoops. Get in there, you. Okay, cool. And the iron. Just gonna anchor pin 1 here. So that that's secured. I'm also going to just like to do some downward pressure and reflow the thing just to make sure it's solid. Actually, I think I made it worse. No, actually, it's good. Okay. Okay, it feels good. Let's do the other end. Okay. So that should be secure. Now I'm just gonna put it in the clamp, finish the rest of the pins. to take a look at those. I can't tell if it's flux or if I bridged those two, so I'll look under the microscope as soon as I'm done. Alright, let me just make sure those two aren't bridged. They look okay to me. Yeah, that's just flux. Alright, cool. Very good. Okay, so let's mark off these things. So we've got our transistors, and then we've got the socket. We have not placed the IC yet. We've got the 10-pin socket, and now we're just on to hardware and faceplate stuff. So let's place the jacks. That's I was about to do it on the wrong side, and then there's text there, and don't ask me why I was placing them on the wrong side. I think I would have figured it out pretty quick, but I was like, what does that text say? And I looked at it, and it says, remember to place jacks and pots on other side. Good call. Thanks, Ben. Don't ask me why I was doing it on that side to begin with. Just spacing out, I guess. Okay. Really should have done the pots first, I guess, because they sometimes are a little tricky to snap in. I hope it doesn't jar the jacks loose now that I did those. But it should be alright. There we go, that one's fine. There we go. Alright, let's mount the plate. Okay, looks good, everything's flush. I'm gonna go ahead and place these washers. Lock these down. Okay. Now let's lock the jacks down. And really, when you're doing this, you don't actually have to do every single one. You can just kind of do the opposite ends, or the idea is to make sure that the faceplate is flush and solid, but I just end up doing them all because if everything works well, then you don't have to redo anything. You solder everything, and then that's kind of all there is to do except put the knobs on. So. Come on, buddy. There we go. I would probably save myself some time if I would just stop being lazy and go get my socket for these. But it's fine. It's whatever. Doesn't take that long. The hard part is when there's like a burr or something in the thread and then it just sticks. Which several of those did. So. Okay. Alrighty. That feels secure. Let's get it soldered. Okay. Let me clean the tip. And start down here. Those two might have actually just bridged. I might have to fix that. Maybe not. That might be flux. I'll take a look at it under the microscope. Okay, close. Let's do the leads here on these. Okay, there's these, so then let's just do these. And again, I think it's generally dealer's choice whether or not you actually solder these, but I always do. Okay. Alrighty. That's looking good. Let's take a closer look. I want to just double check a couple of those jack leads, make sure nothing's bridged. At some point maybe I can set up a camera with the microscope here so that you can see what I'm looking at when I'm looking at this, although it is a binocular microscope and that would kind of eliminate my binocular ability, but you know, it's better than nothing though still. But anyway, it's looking good. Nothing bridged, it's just flux. So let's place these on. And again, I'm just going to test all of these modules as one big batch and see how we're doing. Are those the same? There we go. I think that's... Yeah, there we go. That's right. All right. Let's see. Yep. Okay. Range looks good. Let's place the IC in here. Again, I always wait for the end for those just in case they're sensitive. So we're going to be using these. Straighten those legs. And then just press it down, place the chip. Looks good. That power header is just the tiniest bit off on the one side. Oh well, it'll be fine. I'm like very OCD with straightness of things and stuff. I don't know, that's the designer in me, I suppose. Okay, so we've got ourselves a VCA. We'll place that aside. And let me just... I think I need to pause for one moment just to run over to the house and get myself some water because I realized I didn't bring any over. Totally forgot. So I'm going to take a quick break. Okay, it's later than I thought it was because my clock has not... I have an atomic clock that apparently has not picked up the signal since the daylight savings time change, which is surprising. The one in the house has, but anyway. Alright, so we're about a little over 2.5 hours in. We've got ourselves 4 modules, and we will have a 5th shortly. Let me just do this while I take a break. Let's place these here so we can see how far we've gotten. Turn that off for the moment because we don't need that noise. Okay, so I will be right back. Let's do that. I will resume in just a moment. See you shortly. clipping when I moved the headset there. Sorry about that. Sorry about that. Okay, that took a little longer than I intended, but we're back. I turned into a bit of a social call because my partner Patricia is working from home today as well, so ran into her and also decided I was in the mood for a latte, so made myself a latte. Alright, let's get back to it here. We're almost wrapped up with the build for today. Oh, sorry, let me check one thing. Okay. Alright, looking good. So, we've got our simple little mult. We've got the mixer. We've got the attenuverter. And we've got the VCA. We've got one last build to do for today, which is the VCF, voltage controlled filter. So, let me finish marking up this sheet from the prior build. All right, so as always, we'll run through the information here in the book, and then we'll get on to the build. Let's move that out of the way. All right, so voltage controlled filter. The VCF is the kind of module that gets the most attention in a synthesizer, and for good reason. It sounds great. In electronics, a filter is generally a circuit that filters out certain frequencies from a sound. This is the main feature of subtractive synthesis that imitates dampening and resonance of instruments. There are different modes in filtering, and the main three are low pass, band pass, and high pass. They are exactly as named. A low-pass filter passes only the low frequencies, a high-pass only the high, and bandpass is a mix of both the low and the high, passing only the middle. This imitates the way sounds are naturally filtered in the real world by instrument bodies, or, for example, how you can achieve different timbres by changing the shape of your mouth. When you crank up the resonance in the VCF, you get the famous squelchy sounds of acid house. This imitates the resonance of an instrument body, but to an unnatural sounding extreme if pushed far. Resonance can be thought of as standing waves, where frequencies are folded back and happen to match oncoming frequencies, and they are emphasized. Pass bands are not brick wall, meaning they don't suddenly drop frequencies after a certain point. This is simply not possible in electronics and won't sound very good anyway. This VCF has two 6 decibel per octave filter stages that are added together to make it a 12 decibel per octave filter. This means after the cutoff frequency, the amplitude of frequencies drop. For low pass, 12 decibels for every doubling of the frequency. For example, if you fed a sine wave, which is a pure single frequency, into the filter and swept its pitch, it would be the same amplitude until its pitch hit the cutoff frequency, and then its amplitude would drop 12 decibels every octave. The main thing that you will be plugging into this module is the VCOs, which are rich harmonic sounds full of different frequencies. Controlling the VCF with an LFO or an envelope will create some very nice timbres. Turning up the resonance brings out some overtones in the sawtooth wave, and pushing it too hard will turn it into a messy, squealy sound. VCF module. The filter has two inputs, in 1 and in 2. Both are the same. They are just there to simplify patching. It means you can put both VCOs into the filter without having to put them into a mixer first, or you can put any other sound and even its output back into its input. So it's feedback patching, nice. There are two outputs, bandpass, which is bandpass, and low pass, which is low pass. These are the two filtering modes as mentioned before. Bandpass gives a vocalish sound, and low pass is your classic filter sound. Cutoff knob sets the cutoff frequency of the filter, and resonance knob sets the resonance. Cutoff CV input changes the cutoff frequency. The specifications are 2 milliamps on the plus 12 volt rail, 2 milliamps on the minus 12 volt rail. It's saying it's about an hour for construction, and it's a medium easy build. VCF circuit description is, if you look at the schematic of the VCF and compare it to the VCA, you will see that it is pretty similar. That is not an accident. The VCF is just a cascaded pair of frequency selective VCAs with some feedback. This circuit is known as a state variable filter, which means it can output various states of filtering simultaneously. Other filters can only do one state, low pass only, for example. Below is an example of a fixed state variable filter. So here we have a circuit diagram of a fixed state filter. A state variable filter normally consists of two inverting integrators and an adding and subtracting summing amplifier. Normally the OTAs take the place of R1 and R2 in the above schematic. That would be, yeah, there and there. Okay. And we still have the op amps acting as the buffers and the summing amp. But as this design is slimline, the OTAs perform the functions of the summing amp, and we utilize the LM13700s. Sorry, I don't know the best way to pronounce that, but buffers instead of op amps. We use the negative and positive inputs of the first OTA as the summing input. Unfortunately, this means we lose the high-pass output as it is lost before we can connect to it. You can see the negative and positive feedback depending on where the outputs are fed back into the respective positive and negative inputs of the OTA. It is a very clever design and originates, as far as I can tell, from the LM13700 datasheet. Looking at the main schematic instead, you can see I put two audio inputs using summing resistors, R12 and R6, that are fed into the positive input of the OTA. This lets us add a simple summing mixer into its input. Now, on its current output, U1C pin 5, instead of a resistor to ground like in the VCA, there is a capacitor. This creates a low-pass filter as fast changes are absorbed by the capacitor. The signal passes back out the buffer of the LM13700 UID. I always want to read it as 137, and then I'm like, wait, no, but there's zeros, and yeah, sorry, that's and back into the positive input of the second OTA configured in exactly the same way to low pass. Each stage is only a 6 decibel per octave filter, but filters can be added together to achieve a steeper cutoff. 24 decibel per octave filters are simply 4 stages. The mechanism of how the feedback works is quite complex, but you can get the gist of how feedback will cause resonance and different frequency responses. RB1 is resonance, and you can see that more feedback equals more resonance. For construction, it says again a straightforward build, but quite compact and lots of values, so be careful. Take care building. And patching notes. The great thing about this module is in 1 and in 2 is a mixer input, so you can feed 2 signals into the module without volume control. Much like the VCA, you can plug in the LFO or envelope into CV to create effects. Use the attenuverter and mixer to control by how much. You might get a bit of a thump if too much negative CV is fed into the CV input. The BP output will give you bandpass output will give you a reedy vocalish sound, but it doesn't have much range, so you have to use an attenuverter to find the range to suit. And it says take care around the components that are very close to each other. The jacks share a ground pin in some of the cases. Fit them together before soldering. And here we go. So, as always, same procedure. Get started here. I'm gonna reorient this part spin a bit to get these closer to me. Alright, so stick this corner in the clamp here so we can start placing some resistors. Alright, so we're going to start with the 1K resistors. Let's see if I marked them off. First of all, how many is it? So it's 6. Yeah, they're these guys here. So these ones I actually marked for whatever reason, so I don't have to test them. And I've been using that thing to bend the legs, but actually I think when it's on the smallest size, it's easier to just use these little tweezers and bend them that way. Alright, so we're starting on R8, which is there, all the way down here. Alright. R9. R10. R10 is right here. R13. R13 is here. R16 and R17. So there's R16. And R17. And then R10K. There should be 3 of those. Which I would imagine are these. Did I label them? Yes, I did. Okay. So these are the 10K. So R7. There's R7. R15 and R18. R15. R18 is up at the top there. Okay. Then our 22K. Which one? Okay. Should be these. I didn't label these, so we're just going to verify real quick. They put you. $22. Cool. Alrighty. So we want R1, R3, R4, R5, and R11. So R1. Is here. R1. R3. R1, R3, R4, R5, right? And R11, yeah. Okay. R1, R3, R4. R5. Where's R5? R5 is there. Okay, R4, R5, and R11. So close. Okay, there we go. And finally, 100K, which we have here. Start with R2. Which is this one here. R6, R12, R14, and R19. R14, and R19. Okay. Place that. All right. And I also want to place the two diodes while we're at this stage. And those are here and here for D1 and D2. 1. And D2. Okay. So at this point we're ready to solder. Let's just I'm gonna center this a little bit better. How are we looking? Is it, we got a lot of glare. Let's move it to there so it's not so much glare on things. I'm gonna take a sip of my coffee before I start because I also have to turn on the fume extractor. Such a lonely chat, no one chat. I don't know what it is with these streams. All my other streams, people get involved in the chat, but these ones, I guess they're very low attendance and also silent folks. All right, let's get to soldering. Gonna clean the tip a little bit. It's not too bad, but got a little bit of extra stuff kind of clinging on there. So there we go. That looks good. And I'm just gonna start on this side, I guess. Don't seem to be making good contact with the pad here. I'm really struggling to heat it enough. Oh, there we go. Finally. Okay. Don't want any cold solder joints, kids. There we go. A couple of these pads I'm not making making good enough contact, I guess. There we go, that one's good. Okay. That's those. This fan is so loud on the mic. I feel like it's almost overpowering the music a bit. Oh well. Better that than inhaling whatever it is that I would be inhaling without it. Okay. Okay. I think that's everything for that. Cool. Let's trim these leads, clean everything up a bit. Looks good. Yeah, and there's gonna be a couple. I mean, I basically always kind of reflow all of them just to be safe on the underside, but there's a couple that definitely need of extra. Whoops. Oh my goodness. I somehow caught the edge of the PCB and just like pulled up the UV coating instead. I hope there aren't... I don't think there's any traces there. That it doesn't look like it. Well, that's unfortunate. Hopefully I didn't damage anything. Gotta be more careful with these clippers, I guess. Okay, that's all that. I'm just gonna go ahead and clean those up a little bit. I just like making sure that the full pad is covered in solder, because it doesn't always flow all the way through to the other side. In fact, a lot of these didn't. Obviously, if I was doing some kind of production build or something, I couldn't take this luxury, because I couldn't be having things take this long, but these builds are for me, so why not? It is sort of like soldering everything twice, so it's a little silly, but I'm happy to do it because it just makes sure that everything's good and solid. All right. So that's that level. Now let's do the caps. I'm going to mark off the resistors real quick. Okay, there's those and the diodes. Alright. All covered. Alright, so now our capacitors. C1 and C2 are the 471s here, I believe. That should be what these say. Yes. So that is C1 here and C2 here. Okay, and then the rest, so C3 through C6 are these guys. So we'll just go in order just because. C3, C4, C5, and C6. Okay, again I'm going to just toss this end in the clamp here, keep it steady. I'm going to take a sip of my latte real quick before I get started while it's still hot. More accurate to say while it's still lukewarm. All right. Alright, so again, just to kind of anchor them, I'm going to do one leg of each of these on the top side and then flip it over and solder them properly. Or maybe I'll do both. Sometimes I get weird about it and like feel the need. I don't know why though. It's like a visual thing. Like bothers me that just one of the pads is soldered. Not that that's a good reason to do it. Got this one over here. That's good. Let's flip it, do the other side, then we'll... maybe I'll clip the leads first, I don't know. Yeah, why not? Actually, every single one of those needs solder on the underside, so none of it flowed through for whatever. I don't know why with the capacitors, maybe I don't hold it as long on the capacitors, but it, like, rarely actually flows through when I do it topside like that. Okay. Let's trim those leads. Okay. Is it looking all right? So that's our capacitors. Let me just mark those off real quick. So got this guy, the socket, and the power header to handle. So let's do sort of in height order, I guess. I don't know which one's taller, this socket or this guy, but not that it really matters. So I'll start there. Again, same as last time, just going to anchor one pin. Or two. I don't know why I'm feeling inclined to make things even today, but I am, so whatever. Okay. So that's the 3906, that's in place. Gonna trim those leads real quick. Seems okay. Alright, so let's do the socket next. We'll line up the notch with the notch on the silk screen. Standard procedure, hold it in place. Get a little bit of solder in the alligator clamp there, and just lock in the corner pins. So pin 1. And I'm being very careful not to touch the pins I'm soldering, just to be clear. Alright, so let's lock this in and finish those. Just real quick, gonna just wanted to reflow those real quick for really absolutely no reason other than cosmetic. Alright, so there's that. Let's do the power header. But that's looking good, it's all flush. Everything's looking solid there. So now, notch on the header is on this side. I'll place it. Same technique. I just try to make sure it's as straight as possible when I do this. Sometimes does require like putting a little bit of pressure in the middle to make sure it stays even and flush. There we go. Solder wasn't cooperating right away. Checking my finger placement so I don't get a fun little burn when I do this. Okay, there we go. I'm just going to, real quick, just reflow that a tiny bit, straighten the header out. There we go. Alright. That looks good now. So, let's get the rest of the pins. Alright, looks good. We're just about done here. Alright, so now let's place the jacks. That's not very secure. Let's see. There we go. That's a little better. And something on the other side just to keep it stable for now. That should be enough. Yeah, that's pretty good. Alright. Actually, I'm going to do the pots first. Actually, it would have been easier. Hold on a second. I'm going to place these while I'm holding it because it's easier. There we go. Again, all the pots in this build are 100K. So I don't really have to check the parts while I'm doing this. They're all the same. Okay. Let's place the jacks. These ones share the ground, so okay. Release that. Let's lock the pots down first. This time. Place those washers. Not really any difference between the two sides of these nuts, so. Okay. And then let's lock down the jacks. Turn on there. Okay. All right, those are locked down, hand tight anyway, which is good enough for now. Just gonna go ahead and clamp these so it's nice and stable. Try to reduce the glare as much as possible there for anyone watching. Clean the tip of the iron again. And we're just gonna go from like right to left in this case, I guess. few more. All right. Looks good. Yep. Looking good. Let's place the chip. Straighten the legs. Ooh. They're straight that way, but not that way. There we go. Okay. Notches on this end, so we'll orient there for pin 1. Okay. And let's place our knobs, and we should be ready to test all of these modules. This will be the moment of truth. Okay, I think that's good. Nope. Hang on. Which one do I want to change? That's the full open. Now wait a second. I guess they're not quite aligned. Alright. So let's fix the bottom one. Ooh, that's really on there now. There we go. Usually I can get them exact, but in this case they seem to be just slightly offset from each other, but that's alright. Whatever. Yeah, I don't know what that's about. Okay, I just accidentally flung that across the room. It's actually went under the bench here. While I'm down here, I might as well get this washer that I dropped earlier. Alright, well, we should be done with soldering for now, so I'm going to turn this off. Let me get my headlamp real quick so I can figure out where that knob went. I mean, I could just grab another one for now, I guess. In fact, yeah, that's all I'm going to do. Let me just grab a different one. I'll come back to that. Turn the iron off for now. Oh, and the desoldering station too. Okay, let's see. So we'll match with as best as I can with that orientation there. Okay, that looks better. Yeah, it's not exactly. That's interesting. That's the first time that's happened. Those pots aren't 100% perfectly aligned when they're in the same position. Should be alright though. Okay, so alrighty, so let's see. Well, first of all, let me put these op amps back because we don't need them for now. that away. And we're gonna need 4 power cables. Just marking off this sheet here. I believe we've only got 2 modules left in the build. It's just going to be the LFO and the envelope. And then that's the kit. So here's the modules. I'm going to set those aside for a second. Set this parts tray aside so I don't knock anything. We'll get this kind of out of the way here. Okay. Alright, get that out of the way so we have some room for the case. Let me get the cases. And I'm also realizing, well, actually no, I think that is correct. Alright. Those feel sturdy. So let's think about placement here. Now the VCA needs to have nothing below it, or else it won't fit. My lovely hole tapping skills here. I just like bumped the thing and the screw came out. Yeah, I gotta repair those. But anyway, so my inclination would be to do oscillators, VCF, VCA, and then, you know, easily can kind of patch different orders and stuff there. But because the VCA needs to have nothing plugged in below it, I need to make sure that that can function. It might need to be the other way around. So I might need to put the VCF here and the VCA here. There's a fair bit of gap between those two. Interesting. Yeah, they would go roughly there. And then, yeah, okay, that could work, I think. I have to see, so it needs to be, yeah, so it would be that header there that would have to be empty. That should be alright. Alright, let's see about that, and then we'll do the mixer and the attenuverter over on this side, and then put the mult between them, I guess. I don't know, these can always get moved around. But I do have to tap these holes. One thing I want to see real quick. Oh, let's let's not mess with my headphone cable is like wrapped around the chair there. All right, let me check something here real quick. Because I should over here somewhere, yeah, have a second M3 tap. The one I've been using was seeming a little weird, so I'm gonna replace it so that I don't have hopefully as many issues as I was having with getting functional taps out of this. I was maybe just rushing too much though, I don't know. So, oh, other way. No, wait, no, that is right. Why is that binding up? There we go. Okay. So, if the VCA is going to go here, then that'll be those two holes. So let me very, very carefully tap them. Let's see if I can do this without ruining them. Oh, it would help if I'm going the right way. Okay. Hopefully that was all right. Okay. Can't tell if that second one was any good. Felt a little funny. Oh, 1 second, I need to get my screwdriver. Be right back. Okay. I don't know if that's the right bit. Let's try that one. All right, so let me get the screws out from the hardware bag. See how I did tapping these, although actually, now that I think about it, I need to, because I'm going to be covering up the power header that I need for these, so let's place those down there. Let's place this cable in for that header. One here for that header. So we'll go with this for, let's just make sure, yeah, red stripe. We're all oriented right with the right way. Looks good. And let's see how we did on, this needs to kind of fold down and get under here. Oh, great. Sorry, just knocking the malt out again. I should, you know what, let me, I'm gonna do the gaff tape thing on that one too, so that, wait, where'd my gaff tape go? Oh, there it is. Just gonna tape that one down so I stop knocking that screw out that way. Fair enough. That should hold for now. Let's slide this under. And I kind of need this cable out of the way a bit so that there's room for this. Okay. Now, that looks good. Here's hoping that these taps were successful and I didn't just make a bunch of mess instead. So let's see how we did. That's good. That one's good. Let's see about the lower one. So yeah, maybe it was the tap. Maybe I just needed to replace it sooner. I don't know how fast they wear out. I'm kind of new to this, so. All right. So that's good. So let's just make sure there's room enough for the power cable for the VCF here, and then let's tap those real quick, and then we'll place the VCF in. But yeah, that's looking good. I'm just gonna real quick back this screw out just a tiny bit. Oh, I guess that isn't really doing anything. I guess I messed up that tap too last time. Oh well. Okay. I was just gonna try to slide the module over a little bit, but it doesn't seem to matter or be doing anything. Boy, that's a bunch of taps I messed up last time. Okay. Anyway. Moving on. Carefully tap these holes. Okay, there's one. I don't know if that one really fully activated, but let's see. Okay, now in this case, yeah, we're saying red stripe is there. That's good. Not a whole lot of room under here with all these cables bunching up, but I guess this sort of thing is why not everyone likes that we have sort of landed on ribbon cables as the power setup for modular. But, you know, it does work well enough, I guess, sort of. I mean, it's... people haven't replaced it, so it can't be that bad, right? I guess. Okay, so let's see if I was successful again. Yep, good. And now I don't know about this bottom one because I couldn't even tell if I fully tapped the thing. Oh, no, not really. Okay. So let's back that out. Looks like there's still a little work to do there. I will just carefully do it with the module in place, I guess. I think that's good. Yeah, that seems fine. So then... cool. That one's solid as well. Although actually, let me straighten the module out. I've got to back it off a little bit. Okay. Darn it. Feels like when I don't know, did I strip it? I might have stripped it now that I went to, ugh. Okay, whatever. It's fine. I mean, it's holding. Alright, so that's those. So now I'm just going to go ahead and grab my Sharpie and mark the holes that I want to tap. That one, and that one. Move them up to the top and do the same thing on the bottom. Oops. If I can. If I can keep them stable. Okay, so it's going to be this one, and this one. Cool. Now I can take these out. And I can try to tap those holes real quick, hopefully successfully. There we go. I'm just gonna work one at a time here, so I guess we'll go with the mixer first. See if I succeeded or failed. Every time, like when I was first doing the taps in the case, the first whole bunch were successful, so I got overly confident, I guess. Now I just feel like, oh, I probably screwed that up, but guess I'll have to look into repair kits for the ones that I did mess up, but gaff tape works too. Doesn't look as good, but alright, so okay, that one seems good. Always a good sign when I can actually tighten them. Alright, those were both good. Sweet. So we've got our mixer there. Let's tap the next set of holes. And then same for this one down here. I'm just going to go ahead and do the other set too while I'm at it. Oh. That might be the problem right there. Like the drill kind of wiggled when I was changing directions. I also just noticed that some shavings fell into the power header, so I got to make sure that don't stay there. I don't think aluminum is particularly conductive, but nonetheless. Alright, so that should be set, if I didn't ruin them. Just making sure that those are cleaned out. Don't want to cause any shorts. That would not be good. Okay. See if we can gauge success again here. Whoops. Okay, I can kind of see like there was a little bit of wiggle when that screw went in, but it did work. So I didn't ruin that one. That's good. Just a little wiggly, but the screw's tight, so that's okay. Oops. Alright, that one is okay. Doesn't feel like I can tighten it fully, which is a shame. It's good though. It's solid. It's just... Alright. Don't hire me to tap holes in aluminum for you. You will not be satisfied with the results. I would actually probably be much more careful in a more I don't know, this, I guess with this case, the case is very got like a DIY ethos to it, so I don't worry too much. I kind of move quickly with it, but I feel like it leaves me kind of wanting a drill press, because that would probably be the most reliable way to tap these holes. I do not currently have a drill press. Okay. Oop. Alright, that one seems a little stripped at the very end as well, but it's holding strong, so that's fine. Alright. So, try to be a little less clumsy about this than I was last week, but I think we'll try testing these off the modular in the other room, because that's going to be the easiest way to just patch in. Set this aside for the moment. Alright, so let's see. We're getting there. We're almost done with the thing. So let me do this. Oh, now come on. I missed that one. These freaking bots. I assume it's bots. If it's a person, then could at least contribute to the stream a bit and chat if you're gonna spam me. Anyway. Okay. Let's do this. My messy desk. Alright, I'm gonna lose you for a second here. Let me mute my mic while I transition, because I have to disconnect from the sort of extension that I'm on here and head to the other room. So 1 second. Okay, I'm back. Sort of. I'm gonna set my headphones down for a second so I can go get the kit. I'll be right back. Alright, so first let's power up and make sure we don't have any surprises there. So, whoop, I'll plug this in back here. Get this cable out of the way. Okay, it's all looking good. No magic smoke or anything like that, so no immediate shorts, no major problems. Let's start there. And I'm going to set my headphones down one more time because I want to get, well, first of all, let's, oh, I'm caught on something here. Oh, yeah, there we go. All right. First, let me turn on the behemoth, which is the modular here. Now, I don't, when I have a profile for these streams with all the views set up, and I don't currently have one that includes the modular. One second, let me fix that actually. Give me just a second to get a view ready that will work well for what we're doing here. 1 second.